Good morning, everyone. My name is Matt Minner with Catalyst Connection. I'd like to welcome you to our next digital discovery session. Today, we have Stephanie Steren-Ruta with the Manufacturing Futures Institute, MFI. We're going to talk about getting smarter with your data. Welcome, Stephanie.
Hey, Matt. Thanks for having me.
Yeah, no, glad to have you. And before we get into Stephanie's presentation and learn more about capturing data, improving processes, and how you can go about that, we're just going to do our quick overview of Digital Bridge for those who may be new to our digital discovery series. Digital Bridge is a EDA 2023 Build Back Better program. This is across Southwest Pennsylvania, part of the New Economy Coalition. And it's really focused around supporting regional manufacturers with technology adoption. We do have a broad team that's supporting the program. Catalyst is the lead, but MFI, which is part of the reason that Stephanie's joining us today, is one of our 5 partners that we have working in various areas on this project. So we're really glad to have such a diverse and well-equipped team. And that team does provide a wide range of resources, from technical assistance to demonstration facilities. We did provide access to capital, albeit all those programs have been committed, which is a really good thing, but there is still a lot of support that you can access, like our Pennsylvania Robotics and Technology Fellowship Program. These are no-cost projects, work with Pitt graduate students, in addition to other low or no cost technical assistance through our various partners. And while today we're talking on the data side, Digital Bridge as a whole is eligible across the entire Industry 4.0 technology spectrum. So don't let that deter you from working on any other projects or reaching out on any other opportunities you may have. And lastly, we hope you can join us for our upcoming sessions. Next time on February 27th, we're going to have Cora AI. They're going to be talking about how you can leverage, or more effectively leverage rather, your organizational knowledge, things that every manufacturer has, whether it's in someone's mind or in a spreadsheet or on a document on someone's desktop. There's a range of information, and they're going to talk about some systems that can help you better leverage them. And as always, you can access any of our webinars on demand on our digital discovery playlist on YouTube. So with that, Stephanie, I'll make you the presenter, and you can start to share your slides and get started. And just a note for those on the line, we do have a questions tab that you can use, or just drop it in the chat. Because we definitely want to take your questions, and anything that you may have for Stephanie or in this topic area, please drop that in. Look forward to hearing from you.
All right, come on. Everybody, can you see my
All
screen?
right, it's coming up, Stephanie, so go ahead.
Can you see my screen okay?
Yes, it's coming up.
All right, great. Hello, everyone, and welcome to this webinar. Thank you for being here, and thanks, Matt and Catalyst, for the opportunity. So first, I wanted to talk a little bit about myself. My background's in electrical engineering. Currently, I am an advanced manufacturing engineer for Carnegie Mellon at the Manufacturing Futures Institute. My goal, I work very closely with the research and the research project supporting the digital backbone and the digital transformation through data-driven and AI and ML applications. Before joining CMU, I had an extensive career in the tire manufacturing industry, where I worked globally, working on process upgrades and automation. And so a little bit about the Institute. So we are actually located at Mill 19, and our building, the Manufacturing Innovation Center, actually is home to Catalyst Connection, the ARM Institute, which is the Advanced Robotics Manufacturing Institute, and ourselves, which is the Manufacturing Futures Institute at CMU. We have 4 main pillars at CMU. One of them is to create and conduct groundbreaking research. We want to be at the cutting edge of manufacturing research. We want to educate manufacturers and innovation leaders. We want to accelerate research translation. So, and a lot of times you have things that come out in research and then it takes a long time until it's on a plant floor. So bridging that gap, and then also engaging with our partner and our communities, reaching out and building the next generation of manufacturers. Next slide. So today I'm going to be answering some key questions and talking about them. One of them being, what is a digital backbone and how do you start to build one? How do you determine what is considered useful information, and how do you leverage technology for analytics? So what is a digital backbone? A digital backbone is an infrastructure that enables efficient and secure management, storage, and sharing data across various systems and applications. The main topics we talk about is we want to connect our machines to the digital backbone. We want to collect that data. We want to gather whether it's from your machines, your sensors. We want to contextualize it. We want to give it meaning. Where is it coming from? What was going on at that time? And then on the other end, we want to archive it. We want to save it so that we can then also view it in the future when I have access to it, and we want to be able to analyze it. So at MFI, we have a digital data backbone architecture that we have built out. On the left, you can see is our architecture, and I'm going to be diving deeper into each portion. But when we were building out this architecture, there are a few things we wanted to keep in mind. We wanted to make sure that it was scalable. We currently are working on our facility here at Mill 19, but we want to extend to campus or other universities, so have that ability to scale. The other part is we wanted it to be interoperable, wanted to allow seamless integration to our system, make it easy to switch out or add in a new machine, and make that as easy as possible for the users. And then observability, wanted to have the ability to have tracing and logging and make it easy to troubleshoot. So with that, we are using what is called a unified namespace, which is an architecture pattern. And I'm going to explain a little more of what the unified namespace is. I've heard it as a buzzword of things going on, but sometimes I feel like this graphic really gives a great representation of what it is. So normally you might have point-to-point connectivity where you have your machine and you're sending it to your SQL database or to your storage. But the thing about the unified namespace is it goes to what you might think of as a data hub. So all your information streams to your data hub and then gets pushed to your storage. So that allows a lot more traceability and easy to scale. So at the bottom layer, we have our data generators. The data generators are the machines or your sensors or your IoT devices. They generate data in some way or another. For example, for Haas, it had a module where it communicated through a protocol called MT Connect, and we wanted to capture that data. So we created an event listener that sits on an edge device. An edge device is basically just a computer that sits next to your machine. The reason for having that edge device is because we want to first make sure that if the system goes down, you have a way to locally store your data so you don't lose any data. And then on the other side, we want, if we were to do closed loop feedback, we want to be close to the machine so that there's not much latency between the data getting, analyzing it, and then sending back the feedback for the machine change. So once we get to this MT Connect and it sends the data, we have an event listener. So the event listener is saying, hey, give me all this data from this machine. On the other end, it also is translating, so it's going from MT Connect or OPC UA or Modbus, and it's translating it in an MQTT message because we're using an MQTT broker. So we need that translation. The event listener, we currently have one for MT Connect and some other applications. So on our website, you can go in there, grab your event listener, download it, and use it. It's all open source. So that is our event listener. It basically does one, it translates from whatever protocol you have to MQTT, and then also it's listening for that change of data to grab the data. So we are using an MQTT broker that follows a pub/sub model. The pub/sub model streams, you have all your data streaming to from your machines to this broker, and then you have your connector that is subscribing to it. So example is a newspaper where you have millions of articles that are constantly being published. So that is from what you would call the edge device upwards. And then on your end, you just want the newsletter about animals. So you're subscribing to just the newsletter about animals, and it streamlines that data to give you that information. Similarly, that's what the connector is doing, is saying, I only want this specific data, please send me that, that one. So our connector is subscribing to the broker and also pushing the data to our database. So it's saying, I want all my time series data, or I want all my images, and storing and sending it to our storage for storage, and figuring out how you want it stored. For example, if you're storing in a file storage, you might have a certain hierarchy that you want to follow. So the connector does all of that. Also, that connector is available on our webpage. So if you want to download it and use it for your application, you can. So our cloud storage, we currently have 3 different types of cloud storage because it saves different types of data. So on one end, we have our cloud file storage, which is a partition drive. Currently, it holds things such as images that are sent to our digital backbone or point cloud data that can't be stored in time series or tabular data. For SQL, we are using for metadata, basically the contextualization is what project was that for, what was going on at that time, what was our setup. So giving us information about what was going on. In a manufacturing setting, it might be where is it located, for what machine it was, details like that. And then on our time series data, it's just a value at a time. So for example, here we have our force data from our robots, and today at 10:45, it might be 0.7 newtons, and then in 10 seconds, it's going to be 1 newton. So just giving us those values as time goes on. So that time series data. We currently are using Aviva Pi, which is a licensed software, but with the flexibility of our system, you can switch this all out for, so the time series data, you could use things such as InfluxDB. The cloud file storage, you could use Azure, AWS. So a lot of flexibility in our system that doesn't cause issues. So back to our whole system as a whole, you have your data generators that are streaming the data, the event listeners that are gathering that data and then translating it, our broker, that's our hub for our unified namespace, and then our connectors that are saying, hey, I want this specific data, and storing it into our databases. And that's our overall architecture for that. And our event listeners and our connectors are all available on our webpage. And then also For example, the MQTT broker, as long as you're following a pub sub model, that can be switched out for some other. So for example, Kafka, you can use Kafka instead of the MQTT broker. For our cloud storage, you can switch it out too. And you can easily add on new data generators. So the next question is, how do you determine what is useful information? So on the right, you'll see a list of everything coming from our CNC machine. So it's a long list, and there's a lot of it. A lot of times, usually, a lot of information is coming from the machine. So one of them, the things is, what are you looking for? Context matters. So depending on what you're trying to fix or what you're trying to troubleshoot, that will tell you or direct you in a way of, this is the type of data I'm looking for. Your people, whether it's your operators or your engineers who are very familiar with the system, they have a lot of familiarity and they can guide you in a way of saying this data is important, this data not so much for this context. And then lastly, trial and error, because you have the ability to have all of this data, you have also the ability to try and see what really is affecting your process. So I was going to run through a few cases. So I was recently at a manufacturing plant, and their goal was to reduce water consumption. They had a process engineer that was very familiar with the process. Originally, they had no data, so they were just running water till a fill line and had no control. So they put in a data system that was able to get their fill rate and have it be controlled so that when it gets to this point, we cut it off and not just let it flow and have kind of hope that it's good. So with that, they were actually able to save millions of dollars a year because they were able to reduce their consumption given the data that they had, and they continuously have that controlled. So if it gets out of spec, they can quickly look back and see, oh, this was off. So case number 2 is actually, I worked on this when I worked in the tire industry. We wanted to reduce scrap material. So for this, it was a really big project. It took almost a year or two, and we wanted to see what upgrades and what things would really actually help reduce the amount of scrap. So for the current time, there was no data. We just knew that there was scrap. So I needed to measure out what type of scrap we were getting and how much so that I could tell what was actually affecting the system. So I worked closely with the operators to build out some bins so that they could actually separate out the material by its abnormality and give me data back on, this is how much waste, this was the bane factor, or this was very low. With that, we were able to capture a few parts of the process that could be upgraded. We made upgrades to those processes, and we did then, after that, a control of about 3 months to see if it really reduced, and we had a reduction of about 20%, which also had $1 million of savings a year, and then we did something similarly in another plant. So we were able to use this same data that we got and figure out what issues were happening in another plant that had a similar process. So our last question is, how do you leverage this technology to problem solve? A lot of times you have programs that people will be like, oh, this is the latest and greatest. This is exactly, you need this. But in reality, do we need that fancy program? So for example, if you have a car and you want to get it from point A to point B, do you need that moonroof? Is that really necessary? Not exactly. Is it something you may like? Yes. So you don't need to go fancy to be able to analyze data. Sometimes what we have available to us is good enough and we can make it work. And then the other part is we want to have people have availability to data. If you have the data and it's just being stored, but nobody has access to it and can easily get to it, then your data is not useful at all. And with going back to our fancy programs and technology that we may use, you want it to be simple to use, something that people can pick up easily, so that if you have a new person come in or somebody that's getting trained, they can quickly get up to speed on that. So ease of use is really important when it comes to these softwares. So analytical tools. We currently are using Grafana, which is an open source time series dashboarding, which hopefully I can pull up. So this is our dashboard that we created. You can see the power status on the left. Currently it's offline. We can see all the axes. We can see the axes positions at that time. We can see spindle speed. So this was, and what program is running. So currently we're using that just to get cycle time information and get some data on how the machine is functioning, because previous to this, we didn't have any of this data. So we want to see, track this and then see the effects as we have different projects. So the nice thing about Grafana is that it's open source, so you can just download it, use it on your network. Other software options, some people may have licenses to Tableau, which also allows images to be put on there, or Power BI. And most of us have access to Excel, which is a great tool if you don't have anything else, because at least you're able to analyze, you're able to get those graphics in. And it's a starting point. So back to our key questions. What is the digital data backbone and how do you start to build it? We want to connect, collect, contextualize, archive, access, and analyze. Those are the main things that build up the digital data backbone. On the right is a QR code to our webpage, which gives you more insights on how to build out the digital backbone that we have here at Mill 19 for the Manufacturing Futures Institute. So you're welcome to go on there. How do you determine useful information? Context matters, people matter, and trial and error. All of this gives you a good direction to figure out what is useful for your use case. And then how do we leverage analytics? We don't need to go super fancy. We don't have to. You can, but it's important to make sure that your program does what you need it to do and that it's easy to be used. And then on the other end is we want the data available to the people who need it. Any questions? And we have a feedback survey on the right. If anybody wants to give us any feedback on this, we're happy to get to know if you're interested in more, learning more.
Very good, very good. Well, thank you so much, Stephanie. It was great information. Let's see. So one question that we have is what you've worked, you have some background, whether it's the tire industry or some other companies that you've seen. What do you see as maybe kind of a combination? What are the primary or the best initial steps for companies to get started down this path? And maybe what aspects have you seen that have led to success in some of the times you've seen that?
Yeah, so I worked in both big manufacturing and then also in tire testing. So obviously when you have a big company, you a lot of times have your IT built out, but this is where for us at Mill 19 at the Manufacturing Futures Institute, we had nothing to start with. So our digital backbone and architecture is a great place to begin. We have steps on how to build out your digital data backbone. And it gives you quick tutorials on this is how you download it, and it gives you a starting point for us. So I think if you don't have anything, that could be a great thing. But going back to ease of use and how things, if, you know, for example, at one of our problems, our way of tracking was we had bins and then we were manually weighing it and getting that data back. So sometimes just building out those small processes can help you start to get data.
Okay, very good, very good. Well, we don't have any other questions, so that's I think that wraps it up. But I really appreciate your time, Stephanie, and thank you for the great information. And again, everyone, this will be recorded and made available on our YouTube Digital Discovery playlist. So thanks, everyone, and have a great day. And thank you again, Stephanie.
Great, thank you.
All right, take care, everyone.